Are y'all ready? Let's get into rational functions. Now, this is going to be something you are going to be doing in pre-cal. This is a very pre-cal topic here. So, um, let you get caught up real quick. A rational function has an equation in the form where f of x is the title of our function, but we have a polynomial here over a polynomial here, where a of x equals one polynomial and b of x is going to equal another polynomial. Okay, and that's where it says where a of x and b of x are polynomial functions, and b of x cannot equal 0, because if it equals 0, then we have an undefined function. All right, here we go. If f of x equals a of x over b of x, okay, we're given that criteria, and a of x and b of x are polynomial functions with no common factor other than 1, and b of x is not equal to 0, then we've got some rules here. All of these little bullet points going down are the rules that go with this statement. So we started off saying it's a polynomial with a over b, a of x over b of x. B of x isn't equal to 0. Now let's dive in and talk about the criteria. All right, f of x has a vertical asymptote wherever b of x is equal to 0. Well, think about it. If the denominator is equal to 0, then if the denominator is equal to 0, then we can't have that values there. So we're going to have an asymptote. All right, here we go. F of x has at most one horizontal asymptote. All right. Now, what is this Bobo, Betsy, and Batu? I know. You need to learn these. These are going to be so important when you are like taking a test, or you're going through homework and you're not quite sure which one. Okay, your horizontal asymptote is basically like your vertical shift. This is going to be where the whole where am I? The whole unit either shifts up or shifts down. Now, let's look at Bobo. Bobo is bigger on bottom, then you're going to have a 0 asymptote. So crazy. This is so good. So, if the degree of the denominator is bigger than the degree of the numerator, then the horizontal asymptote is 0. All right, let's look at this first one. Let's see what we're talking about. If I'm given 2x over x plus 2 times x minus 5. Now, remember the other day I told you that you could leave your equations, you could leave your answers, your expressions in either factored form or standard form. But you might have to put it in standard form in order to evaluate the graphs. That's where we are here. Okay, so you need to change this to a 2x over, let's multiply these guys out. We have first is x squared, outer is -5, inner is +2, so that's minus 3x. And then the last is -10. I do want you to get to be able to do this, like get to where you can factor in your head a little bit. Now, right now, we are totally just focusing on asymptotes. We will start going through and talking about other things later. But, okay, so bigger on bottom. I am looking at this little value right here. I'm comparing these two equations. All right, so this is an x to the 1. This is an x squared. So the bigger is on bottom. My horizontal asymptote is going to be y equals 0. Every time. There's no crazy trick. That's what we do. Okay, y'all ready? Let's keep going. Betsy. All right, okay, good. They're all showing up here. Betsy is going to be bottom equals top coefficient, bottom equals top, then it's going to be the coefficient. All right. Well, this one's already factored out for us. Um, and what it's saying is if the degree of the numerator equals the degree of the denominator, then the horizontal asymptote is the leading coefficient. I love it. Okay, so look at these two guys right here. Okay, um, they're the same. They're both to the first power. So x to the 1 equals x to the 1. So my horizontal asymptote here is going to be y equals, look what their coefficient is right here. There's a 1 right there and a 1 right there. So my coefficient is going to be 1. All right. Now, if it was like a 2/3 or 4/5, then that would be my y equals. But this one right here, my leading coefficients were 1s. All right. Let's look at BOC 2. BOC 2 is bigger on top, undefined. If the degree of the denominator is bigger than the degree of the numerator, then there's no horizontal asymptote. You have a oblique slant, an oblique asymptote. It's going to be a horizontal slant. I said oblique slant. It's an oblique asymptote with a horizontal. I'm talking too fast. Oblique asymptote with a slant. Okay, I'm gonna get out of that. I was talking too fast. Now, um, let's look at these. Okay, so I've got x squared over my x. My coefficients are 1, but I don't have to worry with that. So right now, my horizontal asymptote is undefined. Y is, I don't have one. Horizontal, remember, is like the horizon. It goes side to side. I don't have one. I'm going to have a slant. Now, we are going to dive into this when we get over to, let me flip over. Da, da, da. Yes, on example over here, we will talk about the asymptotes in just a little bit. All right, but first I just wanted you to see big, and this is like we're chunking this. We're learning a little bit at a time. Set a bigger on bottom, Bobo, then my coefficient, my horizontal asymptote is 0. Bottom equals top. It's whatever my coefficient is. Bigger on top, then my coefficient, my horizontal asymptote is undefined. We're doing all this, Bobo, Betsy, and BOC 2, to figure out what our horizontal asymptotes are. All right, let's keep going. Now, to find our zeros, zeros are at each real value of x for when a of x equals 0. All right, so now remember, we're going to let the numerator equal 0 here. Okay, so first thing I've got to do is factor this out. So that's going to be, there's a lot of steps with this little lesson here, but I love it. I want us to make sure that we're covering it and make sure that you are understanding it. Okay, so I did my little baby x. I did -3 and -2, -3 and 1, and I just slid those down there in case you wonder where I got those values. All right, I need to take each one of these. I'm going to take x -3 equals 0, and I'm going to take x plus 1 and equal it to 0. All right, so I have x equals 3, and then I have x equals -1. All right, this is where it will cross the x-axis. Okay, is that x equals 3 and x equals -1? Let's look at it on a graph real quick. Let's see what's going on. Now, go ahead and tell me, is it a Bobo, Betsy, or Bot 2? It's a Bot 2 because it's bigger on top, then my coefficient's going to be, my horizontal asymptote is going to be undefined. All right, let's graph this guy. I'm going to do parentheses. I'll let you see it too. X squared minus 2x minus 3 divided by parentheses x minus 2. All right, graph. Awesome, awesome. Okay, so, and as you can see right here, this is where it's so cool. Let me see if I can do it on my pencil here. See how it kind of goes up here? Almost looks like a little exponential growth. And then over here, it kind of goes up and it looks like a little log growth, like a log graph. Um, there is a horizontal slant that goes up through this way. Okay? That is the oblique asymptote. Now, let's talk about where did it cross the x-axis. If I go to my table, look right here. When y equals 0, what was x? 3. Look over here. No coincidence. And then I really want it to be -1. Let's go up here and see if it is. Yay! Okay, so when x equals -1, my y was 0, 2. All right, that's good. We wanted that. Now, let's go here. I didn't put this on the notes. I need to add this to it real quick. To find the y-intercept, we have to let x equal 0. Okay, so with our little equation, we're going to let x equal 0. Well, here's the thing. The fraction of your constant. Yes, this is so neat. So if I take a 0, I'm covering it up, a 0 and a 0, it's going to be the fraction of your constant terms. So, okay, if I were to take x squared minus 2x minus 3 over x minus 2. Okay, and I did a 0 squared minus 2 times 0 minus 3 over 0 minus 2. Well, look at all this. This all cancels out. So that's going to leave me with 3 over 2. Well, really, it would have left me with -3 over 2, and then -2, and then the two negatives cancel out to give me that positive. So now look over here. I'm going back to my graph. When is x equals 0? Right here at 3 over 2, 1.5. All right, there's lots of good stuff going on here. I love it. Okay, so let's recap all this before we turn the page, because I know this was a lot of information. You're given now two polynomials, a numerator and a denominator. They've both got a lot of terms in them. It's Bobo, bigger on bottom. The horizontal asymptote is going to be 0. Betsy, bottom equals top. The horizontal asymptote will be whatever the coefficient is. It was just by chance here, it was a 1. And then bot 2, bigger on top, then the coefficient is going to be, I keep saying coefficient. The horizontal asymptote is going to be undefined, but we're going to have an oblique asymptote. And then to find my zeros, you're going to find the zeros, you're going to set a of x equals 0. So basically, this is like y equals 0. We're only worrying about the numerator here. Maybe highlight that. And then to find where the y-intercept is, we're going to let x equal 0 and solve there. Okay, think about this. Let me say this real quick before I turn the page. If I were to, okay, I want y equals 0, or the function to equal 0. so I can find my real roots where it crosses the x-axis. If I were to let this equal 0 here, and I multiply both sides by x minus 2, they're just going to cancel out. And then that's just going to leave me with this the numerator. So that's why we just don't even fool with worrying about the denominator. We just go straight to um, numerator. Thanks, Santa Claire, help me out. That is awesome. Over x minus 2 times x minus 2, x minus 2. And see how these cancel and this just becomes a 0? That's why I'm hoping that you're able to see that. All right, we're going to keep thinking about it, keep working on it. Let's flip over. Let's do some examples. Let's see what's going on. I feel like I need my coffee. I feel like we're having a little coffee talk this morning. It's a Friday for sure. It's been a long week. Has it been a week for y'all? It has. All right. Remember, we have a couple of things. I'm gonna change pens real quick. I know y'all are like, I'm. There we go. Let's see what we got. We're gonna do f of x. Remember, we have our two polynomials. The vertical asymptote is going to be b of x equals 0. My zeros are going to be a of x equals 0. So those are just some kind of little tricks that we can do here. That's good. All right, identify the zeros and vertical asymptote here. And then yeah, we're just working on vertical asymptotes with these. Yes, and then we're going to add horizontal asymptotes in just a minute. I was like, oh, why did I jump like that? All right, let's factor out this guy first. We've got f of x equals, two numbers I multiply, I get a -4. When I add them, I get a 3. 4 and -1. So that's going to be x plus 4, x minus 1 over x plus 3. Okay, we're going to factor first. Then we're going to find our zeros here. We're going to let a of x equal 0. So that's going to be x plus 4 equals 0 and x minus 1 equals 0. All right, so that's going to be -4 minus 4. So x equals -4. And then I'm just going to jump to it. X equals 1. Okay, that is where it's going to cross the x-axis. Now, let's find our vertical asymptote. All right, we're going to let Mama Stalin. Oh, denominator, vertical asymptote. We're going to let b of x equal 0. All right, so my vertical asymptote, b of x equals 0. So then we're going to do x plus 3 equals 0 from right here. That's where these guys are coming from. So x is going to equal -3. All right, so my zeros are -4 and 1, and my vertical asymptote is -3. These are x equals. Okay, that's all we had to do on that. Y'all okay? So honestly, if you looked at it and it's in factored form, let's talk over this. If you look at it and it is all in factored form, you just need to know that the numerator values are your zeros and your vertical and your denominator values are your vertical asymptotes. That's it. Factor it, label everything. All right, let's do another one. I love my pens right now. All right, I'm going to factor this guy. I get a 6 on top, a 7 on bottom. Two numbers I multiply to get a 6. But add them, I get a 7, a 6, and a 1. All right, so I have f of x equals x plus 6, x plus 1 over x plus 3. Okay, now I can go through and break this all up. Or if y'all just are comfortable, we can say my zeros are going to be x equals -6 and -1. My vertical asymptote is down here. X equals -3. That's it. I mean, literally, that's the answer. Um, so now if we were kind of graphing this and kind of getting it set up and getting our, like, oh, what's it going to do? Here's my y, here's my x. I'm going to have, here's -1, -2, -3, -4, -5, -6. 5, -4, -3, -2. Okay, so I'm going to have a horizontal asymptote here. That is a vertical asymptote. And then I'm going to have a 0 there. So it's going to be something like that when we get ready to graph these. All right, everybody good? All right, let's keep going. Identify the zeros and the asymptotes of the function, and now they're just wanting us to do it all together and graph it. Okay, first thing we got to do is factor out the top. So that's going to give me -4, -3. Two numbers I multiply to get a -4, but when I add them, I get a -3. All right, so then I'm going to factor it. X minus 4, x plus 1. Now talk to me real quick. It's easier to see the Bobo Betsy Bot2 when it's in this form over here. So we need to analyze the Bobo Betsy Bot2 stuff over here first before we move on to the second part. So bigger on top. What is that? Bigger on top. Bobo Betsy Bot2. Bot2. B-O. So this one is going to be Bot2. Okay, now let's go through and find. So we're not going to have a horizontal asymptotes. We can put none here. All right, because of the Bot2. Because of the bigger on top, it's undefined. All right, let's go and write our zeros. We have x equals 4 and -1. They're coming off of these guys up here on my numerators. My vertical asymptote is coming off my denominator. So x equals 0. And is there anything else? Now, this was the example one that I was trying to tell you that we were going to get to. All right, we have got a bigger on top. We need to do division to see x squared minus 3x minus 4. We need to do long division to see what our slope is for our oblique asymptote. I know that's a lot of words. Here we go. Let's do it. X will go into x squared, x times x is x squared. All right, just like we do in normal division, we get a 0. I'm going to bring down this -3x. X will go into here minus 3 times x times x. -3 times x, -3x. Now we subtract down, we get a 0, and I bring down the -4, and I can't do anything with him, so I just stop. I don't have to worry about the -4 stuff. But this right here becomes my oblique, OBLIQUE, asymptote. TOTE, asymptote, yes. All right, so let's graph this guy. I have got a 0 at -1, and I have a 0 at 4. 1, 2, 3, 4. These came from my numerators. I've got a vertical asymptote at x equals 0. It's going to go all the way down here. Now, I don't have a horizontal asymptote. There's not going to be one going side to side, but might help if y'all could see it. You are going to have a oblique one. So I'm going to go down to -3. 1, 2, 3. And I'm going to graph this linear line just like I normally would. Up 1 over 1, up 1 over 1, up 1 over 1. So I have got a oblique asymptote going up this way. Now, I completely understand. You're like, Miss Cole, how in the world would I know to graph all this and where would it go? Right now, as much as I would love for you to be a Picasso at drawing these, I would be so happy if you were just in the correct quadrant, in the correct zone, and all of those values. Let's look at it on a graph real quick, just to kind of help us make sure we are rocking these out. X squared minus 3x minus 4 divided by, now I'm just putting an x. There goes up one, there goes another. Okay, I'm going to also add my little oblique asymptote so he can kind of help us see 6. All right, there's one, there's the other, and then there's my oblique asymptote. Now remember, the asymptote's like a forbidden line. It will always converge to it, but it will never specifically touch it. All right, let's go here to the table. Just if we were on a test and we were so worried that we weren't getting the right, points, and we wanted to make sure our graph was looking pretty. Let's go. We'll go to -2 down 3. 1, 2, 3. All right, we got our -1, 0. We got that point. 0 is an error. So let's go ahead and wait. Can I go -3? We'll just go right about here. Looks like it's going to do something like that. All right. Well, then let's go over here to 1. If I go over 1, 1, 2, 3, 4, 5, 6. 2 is 1, 2, 3. 3, -1/3. I was like, ooh, that got me for -1/3 right there. 4 is 0, check. And then 5 is 1.2. So we're kind of getting the idea here of where our graph might belong. All right, are we good? Everybody okay there? I don't mind if you use Desmos. I don't mind if you use your calculator. Please, let them be your tools to help you figure these out and understand the graphs. All right, let's keep going. This is a big section, y'all. Sorry about that. All right, let's factor out first over x plus 1, x minus 1. I need for you to know that this is the difference of two squares. I need that to get into your brain somehow, some way fast. All right, bigger on bottom. So we have bigger on bottom. This is going to be a BOBO. So my horizontal asymptote is going to be y equals 0. I can go straight to it. I don't even know what the rest of the other stuff is, but I know that I've got a horizontal asymptote at 0 from my coefficients here. All right, my zeros. Those are my numerators. All right, so x equals 2 coming off of this guy. My vertical asymptotes are going to be x equals -1 and 1. Yup. And then, oh, I didn't put this. What's my y-intercept? Remember the y-intercept, flipping back over, what did we say? The fraction of the constant terms. So what's my constant terms? If I were to take, when I have find the y-intercept, I let x equals 0. Look right here, what it becomes my y-intercept? A 2. Looking to see if there's anything else. No. All right, so let's go through and mark these. I've got a y 0 at 2. I've got a vertical asymptote at 1 and -1. A y-intercept, a horizontal intercept at y equals 0. Okay, we haven't seen this one yet. And then a y-intercept equal at 2. Okay, now I can't connect these two dots because there's an asymptote in my way. So I'm going to go to the graph. I could t-table it. I could go through and plug in a -4, -3, -2, -1, 0, and do it that way if you don't have your calculator. But we can pull Desmos up on our phone. Remember, it's not knowing if you know how to do a t-table or a graph or not. I know you know how to do that. It's, do you know how to analyze the graph? Well, all right. Look at that one. It is, let's look at the table here. All right. At -2, I'm down here in this little world. Let's see, look at the graph again. Yep. And then 0 and 2, then 2, 0, and then 3 up here. Okay, so on these, I'm going to take this, I'm going to go down this way. And this one, I'm going to give it a little U going up this way. And then this guy over here, I'm going to give him, let me see. Yes. Now, this is what people don't love. You're going to cross this asymptote here, but then you're going to come back down and converge to it. Oh, that's a big step. But everybody was like, well, why do we cross that x-axis when we're supposed to have an asymptote there? It is the way the graph is right now, and it's because of the way the denominator is in the rational function. So that's what's messing us up a little bit, but not messing us up, messing up our brains. So you're going to go here, and then once when the numbers kind of start getting bigger and you kind of flip them, then they're going to kind of start converging to that horizontal asymptote that way. All right, you good? Oh, I wish we were in class right now so I could just see your faces and answer questions and all that. But we are great, guys. We're going to get this. Okay, let's keep going. This is going to be a long video. Factor out your 4, x minus 3, x minus 1. All right, and hopefully we can speed these up a little bit too because y'all are getting good at them. My 0 is going to be 3, x equals 3 from this right here. All right, my horizontal asymptote is going to be x equals 1. Bottom equals top. So it's bottom equals top Betsy. It's going to be the coefficient. So it's going to be y equals 4 over 1 from this right here, which is going to equal the 4. Y-intercept. Here we go. I don't know why I didn't put these on those notes. Oh. All right, if I cover these up and let these x's equal 0, and that's going to give me -12 over -1, which gave me that 12. Okay, here we go. A 0 is at 3. 1, 2, 3. My vertical asymptote is at x equals 1. Yeah, I didn't give y'all enough room to put this on the graph. My horizontal asymptote's at 4. 1, 2, 3, 4. And my y-intercept's at 12. Well, 12's all the way up here in the front yard. So, let's do this. You're going to go, we know it's going to go here. We're going to go up through this way. And then we're going to go up through this way. And it's going to cross at 12. We're going to say this is 12. Now, you're like, what? You're going to be like, Miss Cole, what did you just do? You have to check some points. If I knew, okay, I knew it was going to be in this kind of quadrant over here because of this x equals this x-intercept. So I knew it was going to be this way. So this kind of graph, it's going to go this kind of this quadrant here and that quadrant there. You are always welcome to check it with Desmos or the or your t-table. Look, if I did x minus 12 divided by x minus 1, it's going to go up that way and over that way. And then I can always go back and show the y equals 1. No, 4. There we go. And then there's the asymptote there. All right, everybody good? Let's keep going. I feel like just keep swimming. Okay, factor at the top. I get, oh, let's do it here. Oh, wait. X plus 5, x minus 3 over x minus 1. My zeros are x equals negative 5 and positive 3 from my numerator. My vertical asymptote is x equals 1. My horizontal asymptote, bigger on top, undefined. It's a bot 2. Okay, so this is going to be none. All right, then, none. All right, so then I need to do x minus 1 divided by x squared plus 2x minus 15. All right, x will go into x squared, x times, now look, I've got to write it over here under this second one. So that's going to be x times x is x squared, x times minus 1x there. It kind of helps us line it up. Okay, to subtract, you add the opposite, you change your signs, and then we get a 3x. Bring this down, minus 15. All right. X is going to go into here, a plus 3 times 3x minus 3 minus plus. So that's going to give me a 0 and a negative 12, and I can stop. Do not worry about the remainder there. All right. So x plus 3 is going to be my oblique asymptote, 1, 2, 3. I'm going to go dot, 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 dot here, dot, dot, dot here. My zeros are at negative 5. 1, 2, 3, 4, 5. Positive 3. 1, 2, 3. Would be great if you could see it. My vertical asymptote is at 1. All right. I think that's enough juice here to go and graph it. 1, 2, 3. That just looks like it was over a little bit. Hold on. Okay, let's go do y equals parentheses x squared plus 2x minus 15 divided by x minus 1. There and there. Delete that. And then it's going to be x plus 3 for our oblique. We go here. We go there. And then there's our oblique. Okay, what made me stop and question was there was this big gap between here. I didn't like that. That's where I was like, I just wanted to go back and double check it and make sure. So I'm going to go here and I'm just going to shoot my graph up that way. And then over here, I'm going to take this and I'm going to shoot my graph up that way. What is my y-intercept? Oh, look, it's going to be 15. Y-intercept is going to be 15. So my y-intercept is going to be up here. Let me, something like that. All right. Like I said, guys, we're not doing Picassos today. We are just making sure that you are getting these. Okay. Now, look at this one. I'm just going to show it to you just because we're doing a lot of work here. Here's another problem. Your 0 is your numerator. Here's your denominator. Your vertical, your horizontal asymptote is y equals 0. You don't have a y-intercept because you have a horizontal asymptote. So no y-intercept because of that right there. And that's it on that one. Okay, flipping over. Last bid. Hallelujah. This is a big video, folks. We are learning today. All right, a continuous graph. The graph is continuous because it has no jumps, guys. Welcome to Pre-Cal 101. No jumps, breaks, or holes. You can draw the graph with your pencil and never leave the page. Leave your paper like you are continuously drawing. That's a continuous graph. All right, a discontinuous graph has jumps, breaks, and holes. Point of discontinuity. If a real number for which the denominator or rational function f of x is 0, then a is not in the domain of f of x. The graph of f of x is not continuous at x equals a, and the function has a point of discontinuity at x equals a. The factors of the denominator will reveal the point of discontinuity. So basically, it's like where our vertical asymptotes are. Removable discontinuity. Okay, so look at this. We know when we can factor this out, and then these are removed. X equals -2 is the removable discontinuity there. Okay, there is the hole in the graph is called the removable discontinuity because you can make the function continuous by redefining at x equals -2 so that f of -2 would give you that 1. All right, and then the last one, removable. It's got a non-removable discontinuity at x equals 2. There is not a way to redefine the function at x equals 2 to make the function continuous. All right, a hole is an, where was that? Hold on. I don't know what that was supposed to be. Hold on. Oh, common factor. And it's not supposed to be an AN. Okay, a hole is a common factor in the graph. All right, guys, I'm going to stop here. I'm going to let your brain breathe for a second. Oh, we still had two more. How are we doing on time? I feel like this video is like 6 hours long. We got it. We're doing it. Come on. All right. I'm going to factor this out first. F of x equals x plus 3, x minus 3 over x minus 3. All right. So these guys factor out. So they were a removable yeah, I am not in school mode right now. Removable discontinuity. Okay, so we have x equals 3 is where our hole's going to be. So now, since I removed these, I've got to graph just the x plus 3. 1, 2, 3. But at 1, 2, 3, okay, so hold on, let's do it this way. We're going to go ahead and pretend we have our graph. And then at x plus 3, 1, 2, 3, right here, I've got to put a 0, like a little hole, because it's going to be the whole graph here, but at x equals 3, so this is kind of 3, 6, there's a hole. And I just plugged in 3 plus 3, gave me that 6 right there. All right, let's look at one more. I have x squared minus 2x minus 8 over x minus 4. I'm going to factor these. X minus 4, x plus 2, x minus 4. All right, look right here what happens. They cancel. This is why, too, when we were over a minute ago, we did not, we needed to factor them out to find our zeros and then to find our vertical asymptotes and all that. Well, this is another reason why we need to factor them out, because when we factor them out, I couldn't even see that. When we factor these out, we can see if we have any points of discontinuity. All right, so I'm going to go here and I'm just going to graph this part. 1, 2, boom, 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 boom. Okay, I'm going to give myself a dotted line right now because I don't know where my hole is. My hole is going to be at 4. 1, 2, 3, 4. All right, it's going to be up here. So that's going to be 4 plus 2 is, I liked 6 on that for some reason. Sorry. Okay, so that is going to be my hole for that. All right, y'all good? All right, last little bit, guys. You know what? Let's do this. As much as I would love for y'all to do the word problem right now, we're going to skip this because I need your brain to understand this part. So let's stop here. I will be sure to put the answer on Google Classroom, but I think your brain has like absorbed a bunch right now and a lot of words. So let's stop here. And like I said, I will put all this on Google Classroom so y'all can review it as well. All right. Send me any questions you have.